morning, students. So, in the last class, for the classification models, we have seen what are the factors which need to be tested in order to evaluate the model. One is the accuracy, precision, recall, F1 square, confusion matrix, and ROC, receiver operating characteristic curve, and the area under the curve, which will help you to identify, okay, the validation of the model. So if the area under the curve is equal to 1, obviously it's found to be a perfect classifier. When it is equal to zero point 0.5, no better than random guess. If it is less than zero point 0.5, is worse than the random. So the area under the curve, receiver operating curve, is useful. It gives us a single number to summarize the model performance, works well even with the imbalanced data set, helps choose the best model among several classifiers. So the scenarios which we have seen in the last class for the fault detection in a heat exchanger, when we are building a model to classify the heat exchanger is operating normally or failing. So the normal operation is equal to 0 and the faulty operation is equal to 1. So we have a denser sensor data to train the classifier. So the sensor data is a temperature drop or the pressure drop or the flow rate or all. Okay, so the sensor data for this case is temperature drop, pressure drop, and flow rate. When the area under the curve, under the receiver operating characteristic curve, receiver operating characteristic curve, okay, if it is zero point 0.1, obviously it fits the excellent ability to distinguish between the normal and faulty condition. Even if you adjust the decision threshold, say to reduce the false alarm, the model still performs well. So this we have seen very well in the last lecture. Okay, so the model validation techniques, this is about testing how well your model will perform on unseen data. Okay, so the goal is to avoid for overfitting and underfitting. And coming to the validation techniques, we have different validation techniques. Okay, so the model validation we have seen, evaluation we have seen. Now we are moving to the validation techniques. So we have a train test fit, cross validation, leave one out cross validation, stratified k-fold CV, coefficient of variance, okay, bootstrap validation. So we will see one by one with suitable examples, okay, how these validation techniques will help you to validate the model. Split the data into two sets, training, example 80% and testing is 20%. This is very common phenomena or validation. So usually we will train the data, 80% of the available data and 20% for the testing. Train on one, evaluate on the other. Simple, but results may vary based on the split. Cross validation, k-fold CV. So data is divided into k parts. Let's say you have 10 data is divided into k parts. You have 10 data. I just divide into 5 parts. Okay. So 2 data. Okay. The model is trained for k times. So 5 times it will be trained. Each time using a different fold for testing and rest for the training. So let's say I have 10 data. I just have a 5 different parts. So I just put 2 data. So leaving one out, okay, so that means the model is trained k times, so 5 times it will be trained, each time using a different fold. Okay, so 2 data, each time you will take a different fold for testing and rest for the training. Okay, so the testing and training, when you see the training is 80% and for 20% is the testing. Okay, so this is a train and test split. So class validation for co-fold, they k-fold, they just divide the thing. Okay, leave one out cross validation. Okay, so sorry, the k-fold cross validation. I just coefficient of variance I told, I think. I'm sorry for that. Okay, it's a k-fold cross validation. It's a cross validation. The special case of k-fold where k is the number of samples, computationally expensive but very thorough. Okay, for leave one out cross validation. So we will see and with the examples later. And stratified k-fold cross validation ensures each fold has the same proportion of classes as the full data set. Important for imbalanced data. When it is will be helpful, it is for a imbalanced data. Bootstrap validation. Repeatedly samples data with the replacement to train and test the model. Okay, coming to this type of techniques, the validation techniques like train, test, split, k-fold class validation, leave one out class validation, stratified k-fold, bootstrap validation. So the case and strength for the train and test is fast and simple. The limitation is high variance in result, whereas for k-fold, the case is balanced evaluation, modest computation. So it does not require any complex computation. It's a very moderate k-fold um, class validation. Leave one out class validation best for small data sets and high computation time. So the limitation is high computation. The time consumption is more for the leave one out class validation. When we need to go for that particular case, best for the small data set when the data set is very limited. Stratified k-fold best for classification and imbalance. Okay, in that case, we can go for stratified k-fold, slightly more complex to implement. Okay, so when compared to the moderate computation is slightly more complex in that case. Okay, bootstrap validation may not reflect real world test cases. Okay, so for example, the data which has been found from the distillation column. Okay, so these are real world examples. So if data has been unrealistic, okay, sometimes the faculty will give you a problem where it's not a realistic. For example, they may give a height of the column is 80 meters or 90 meters. Okay, now it's very common. Okay, for example, 80 meters or 90 meters is almost 10 story, 20 story. During our period, 25 years back, when we are doing a problem, when the faculty said actually is 80 meters height of the distillation column, we will laugh. So it's not actually 80 meters. 80 meters is 3 meters is one story. Just imagine, is almost 90 meters means how many stories? 30 stories. So is it possible to raise a column which is with a support of a distillation column of height of 10 stories? Sorry, 30 stories. Okay, so just imagine it's like a giant apartment tower or any tower. Okay, so just imagine. Okay, so these are the things. So may not reflect the real world test cases for bootstrap validation. And coming to the train and test split, the use case predicting the product yield in a simple chemical reactor based on variables like temperature, pressure, residence. So the example, so they just train for 800 samples and test on 200 samples, evaluate how well the model generalizes on unseen data. Simple and fast, but depending on the split, you might miss rare edge cases. Example, abnormal condition. So in a train and split, out of 1000 samples, they are giving 80% of the data as a training and 20% of the data is for testing. So the insight is simple and fast, but depending on the split, you might miss rare edge cases. So the training data, if you have outliers or what you call yeah, uncommon data is found, then it will model will train in such a way that okay using a different algorithms. Okay, the k-fold cross validation. So in this case, predicting the viscosity of polymer melt using features like molecular weight, temperature, and shear rate. So the example 500 experimental records use five-fold cross validation. Train on 4 parts, test on one, repeat 5 times. So you understand. So we have a 500 experimental records. Okay, experimental records. We have divided into 5 parts. So of 100 each. So in that case, train 4 parts and test 1 part. So how can we divide actually this one? Okay, repeat for 5 times. So for each part, 1 part has been taken for the test. Okay, the out of 5 part, 5 times we need to do because 5 different testing parts are there. Hope you understood. So because when I say in terms of training data, you will get confused. That's what I'm trying to explain in terms of the testing data. If you divide that 500 records are 5 parts, 100 each. First 100 is used for training, the other testing, another is all for training. The second part is used for the training and the remaining 4 parts is used for the, sorry, second part is used for testing, the remaining 4 parts has been used for the training. The third part is used for the testing and the remaining part has been used for the training. Okay, so similarly we need to do for the 5 times. That's what they mean over here. Okay, get average root mean square error divided by coefficient of determination r square across all folds. So give a balanced estimation of model performance and how avoids over reliance on a single test set. There is a similar small interpretation, I mean, a small thing which somebody have been talking for the last 5 minutes on the road. Okay, I think that may not affect your what you called my lecture. Okay, because they have a speaker and they have been doing it. Okay, I'm recording doing the daytime. Okay, from my house. Okay, hopefully this will not disturbance for you. I think there is a slight sounds may come. Okay, it may be a noisy sound. Okay, kindly burden with me. Hope you understood what I'm trying to say. So the validation techniques, the first one is train and test. Usually majority of the people will go for this case, and the second one is k-fold what you call cross validation. Okay, so leave one out cross validation. We'll see the third part. So let's say the modeling enzyme activity as a function of pH and temperature, limited data set with only 20 data. So leave one out cross validation, train the model on 19 data sets. So we have a what is the limited data set with only 20 data points. We have a only 20 data points over here for modeling the enzyme activity as a function of pH and temperature. The pH and temperature is a independent variable. The dependent variable is the enzyme activity. We have a data of 20 numbers. Leave one out class validation. So leave one out class validation. We have 19 data points. Train the model on 90 data points. Test on one left out. Repeat 20 times. Okay. So just in that they are taking different parts and then we do it in the previous case. K-fold class validation. Leave one out class validation. We have taken all the data points and then leave one point out. Okay, well, they used to understand the difference between the different validation techniques. And that's why I'm just stressing upon. Okay, so ideal for small data sets in lab scale experiments uses nearly all data for training each time. So ideal for small data sets. So when we go for data set is very less. So for example, if the data set is 1,000 as that of in the first case. Okay, so just imagine 1,000 times giving one times 1,000 times we need to do it. That is not feasible, right? So that is a very highly complex computation. Okay, so ideal for small data sets in large scale experiments uses nearly all data for training each time. Coming to the stratified k-fold class validation, so classifying batch quality in a pharmaceutical manufacturing process. So um, here, if only 10% of the batches are failed, a normal k-fold might result in some folds having zero fail. Use stratified five-fold class validation to keep the class ratio 90% pass, 10% fail, consistent in each fold. Essential when working with the imbalanced data sets. So it is essential for the imbalanced data sets, else in avoiding misleading high accuracy. So avoid misleading accuracy. Please underline the word. So unsatisfied k-fold class validation. What is the example they have given? Only 10% of the batches are failed. A normal k-fold might result in some fold having zero fail. Using stratified five-fold class validation to keep the class ratio 90% pass, 10% fail consistent in each fold. Okay. So in that kind, we will have a imbalanced data sheet, essential when working with the imbalanced data sheet. Okay, so that will avoid misleading the high accuracy. Bootstrap validation, estimating the uncertainty in corrosion rate prediction model for offshore pipeline under different salinity and pH. So the corrosion rate is the dependent variable which depend on the parameters like different salinity and pH. So estimating the uncertainty in the corrosion rate prediction model for offshore pipeline under different salinity and pH. Randomly sample. Okay. Train multiple models. Test on the output of back data each time. Average matrix, mean absolute error, coefficient of determination R square, and look at the standard deviation. The insight provides robust confidence intervals and is helpful for assessing the model reliability under varying environmental conditions. So it will provide a confidence interval and is helpful when assessing the model reliability under varying environmental conditions. So what is this case actually? Train multiple models. We can train the bootstrap validation is train multiple models and test on the out of back data each time. Okay. So average the matrix and look at the standard deviation. So is a randomly sample from the data. So these five techniques: train, test, split, k-fold class validation, leave one out class validation, stratified k-fold class validation, bootstrap validation. For with the chemical engineering example they have given here, why it is useful. So for the train, test, split, reactor yield prediction, fast simple performance estimate. Okay, when you have to reactor yield prediction, it is very fast as well as simple. So usually we will go for train and test split. Majority of the validation will go for the train and test split. There are other types: k-fold, polymer melt viscosity prediction. In that case we will go for a k-fold cross validation because it's more reliable performance check. Leave one out class validation. We will go for it when you have a few data. Underline the word few data points. So maximize the data use when data set is very small, and satisfied batch quality classification in pharma. Okay, so keeps class proportion for better classification. And coming to the last point, corrosion rate modeling, that is an example. Okay, for bootstrap validation, corrosion rate modeling under uncertain environment is good for uncertainty quantification. When we need to go for bootstrap validation, good for uncertainty quantification. Stratified k-fold when we need to go for better classification, a class proportion for better classification. This will keep, this is the advantage. Okay, when we need to go for certified k-fold, class validation and bootstrap validation. So the chemical engineering examples which I would like to highlight. Okay, imagine we are building a predictive models for catalyst activity or reaction yield based on the temperature, pressure and the reactant concentration. We need to be sure that the model is not just fitting noise, it can generalize to new experimental condition. It won't mislead process optimization decision. That's why the robust evaluation and validation is crucial. So why we need to go and do the robust evaluation and validation? That's what it has been given here. So in the last two lectures, I will give you an overview of this thing. Okay, to make you to understand better. Okay, in terms of why we are doing a model evaluation and validation, I go back to the slide. Okay, ELA slide, and just would like to know what is the main objective in a nutshell. Okay, I will explain about this part is very clearly why this model evaluation and validation techniques, okay, is very important in assessing the predictive performance. Why we need to, once the model using the algorithm has been created, okay, why we need to evaluate and validate the techniques. So by validation model evaluation, we will have for regression models like mean absolute error, mean square error, root mean square error, and coefficient of determination. These parameters will obviously will help you to identify whether the model evaluation is good or not. Okay, so for that we have already explained. Okay, with some chemical engineering examples. Okay, and similarly for the classification models, we have a different evaluation criteria points are there, like accuracy, precision, recall, F1 square, confusion matrix, receiver operating curve, characteristic curve, and area under the curve under this particular receiver operating characteristic curve will help you to evaluate the models which is coming under the classification models. Okay, and also we have discussed about the true positive, true negative, false positive, and false negative. Okay, and after that, for model validation, we have need to train the data, train the data, and test the samples by using validation techniques like five techniques: train, test, plate, k-fold class validation, leave one out class validation, stratified k-fold, and bootstrap validation. Okay, so the stratified k-fold and the bootstrap validation have the points actually need to be noted down. So for slightly more complex to implement, that is a limitation, and imbalance based for classification and imbalance data and uncertainty estimation, we can go for a bootstrap validation. So with this note, hope you understood what is the necessity of going for a validation and evaluation after the algorithm has been created and the model has been arrived out. Okay, so with this note, I stop it here. Hopefully you will understand the lecture which has been covered. Okay, so far for the unit 3. So with this note, I have completed the third unit, but I still need to cover, want to do a recap of the unit 3. Okay, so we will have a syllabus. Most probably, the FAT 2 is there or not. We will check. I will get back to you. Okay, so if FAT 2 is not there and FAT 3 directly, we have only two tests in the like the previous semesters. Okay, so in that case, we will have all the unit as a FAT syllabus. Okay, so today is a Wednesday. Hopefully, we will have a face-to-face section. So during the face-to-face section, if you have any doubt on any of the process, any of the thing which has been discussed so far during the unit 3, you are most welcome to ask me. Okay, and in terms of chemical engineering and principles, please try to understand this machine learning principles, how it works, and where we need to apply in a real engineering, chemical engineering field. Okay, so with this note, I stop it here. Hopefully, you will understand better. You might have understood better so far what has been covered so far in Unit 3. If you have still have any doubt or anything, please bring me. Don't hesitate to contact me. Okay, so with this note, I stop it here. Hopefully, you will understand the content which has been delivered to you. Thank you very much.